months. Yeah. Sorry guys, I just got it all rolling, ready for recording. So thanks for making it in again this week. I hope you had a good week off last week. Enjoyed. And I hope all of you are fine with your assignment, handing up feedback, etc. Not all have been marked. Just the last few that came in.
I haven't sent it yet.
No, I
haven't.
I know that. And for that reason, I guess I can't really give too much feedback back in regards to assignments yet, because there are still few yet to come. But also for those at home with the video as well. But so tonight's the last session before the break, for a 2-week break, and we're going to be covering plasterboard ceiling systems, and also if any of you have any questions in regards to assignment 2. So plasterboard ceiling systems, there are two main approaches: the flush jointed system, which is predominantly what you'll see in residential architecture, and the suspended ceiling, which is what you would see in a lot more commercial situations, or retail and restaurants and the like. It is normally what you would see in an institution like the TAFE, except with this building they chose not to put ceilings in, so we can see all the services going on. So suspended ceilings are a type of architectural design element used in commercial and residential buildings. They are created using metal grid systems, which are suspended below the roof or floor above using a series of wires. You can have, and with those suspended ceilings, you can also have a flush plasterboard option. So it can be created using tiles that sit into a grid pattern, or flush plasterboard which sits over top of that grid pattern. So flush jointed system is much as it sounds. It's where all the joints in the plasterboard are taped and flushed over with the jointing compound and smoothed to the desired level of finish. Levels of finish differ between applications where in the building it's applied, or what type of surface finish is going on there, and also there is consideration given to lighting, etc. So if we have bright lighting and lighting in a sense which is perpendicular to the surface, then far more attention to detail needs to be made in regards to the jointing, because any imperfection will show up very well. Various different methods of fixing to the roof or floor above. So suspension rods fixed, to steel joists, timber joists, or directly to the concrete with masonry anchors. And through these bracket systems attached to those. Suspension rod is also threaded through a suspension clip, which clips onto the top rail of the framing system. That top rail may join to a cross rail fixed in this case, a ferry channel perpendicular to that top rail, and in this regard it's fixed underneath. Typically with our suspended tile systems, we have our channels fixed. So we'll have our top rails, which are much deeper. I'll grab a marker, show this. What I don't have is this whiteboard. G'day.
Hello.
Just to catch up, we're talking about ceiling systems in primarily commercial, but also residential applications. We've just covered briefly what's above the ceiling system, so the hanging details, and then be it either a flush plasterboard system with joints, or acoustic tiles placed in there, or plasterboard tiles for that matter. When we have a suspended tile system, typically we'll have a deeper top rail, and just for the ease of drawing, I'll keep that small, and then our perpendicular rails. So this is the one we've got our clip attached to, and suspended from the ceiling. Then our perpendicular rails are much shallower, but the bottom of our rails sits flush, so our tile can sit inside that. So they have fixings here. And that such a system enables very easy access to parts of the ceiling. So we can, for example, if we had a suspended tile system in here and I wanted to access just a part of this ductwork, or so I had a jammed baffle in there, I could just lift up one of the tiles and shift it across, and I have instant access to the ceiling.
So in the case of the what they call the hook that you're talking about, how do you screw that to the concrete?
So that would be with a masonry anchor,
yeah.
and the different types of ceiling system manufacturers will specify their masonry anchors for that. Look, I don't know specifically. I imagine you'd probably want to fix them with a shock-fired masonry anchor for speed of construction, because you've got a lot of these hangers to install. But yeah, the specifics of that, I'm not sure. Other approaches are plasterboard is fixed to the fairing channels with screw fixings. So we have a scenario there whereby we have timber joists and hangers off the timber joists to our top rails, and then fairing channels attached to those top rails, and the plasterboard fixed to the bottom of those fairing channels. This has its limitations in that we can't access the ceiling quite as quickly and easily, but it has its benefits in that we can get a nice flushed ceiling look without the interruption of rails in between panels. Flush plasterboard ceilings may also be directly fixed to ceiling joists. Now this is the typical detail for in residential architecture. So these ceiling, they may be ceiling joists, or they may be bottom chords of trusses. Such a system typically doesn't work very well for if we wanted to have services running through in a two-story dwelling, unless we had particularly deep joists. Flush jointed ceiling system joints are taped and set to form a smooth, flush jointed continuous ceiling suitable for painting. Various ceiling systems are available for decorative, acoustic, and fire-rated applications. So there we have our main, our main parameters for use, or main reasons why we would use plasterboard. But there's another important aspect of plasterboard that's missing off this, that I think is missing off this this slide. Can anybody think of what that important function of plasterboard is? So we've got aesthetics, we've got acoustics, and fire suppression. Yeah, no, that is exactly what I'm looking for. That is what Alex said here is it's for moisture regulation. We do this. Yeah, I said that previously in this class. Yeah.
Is it combined with temperature as well?
Well, yes, plasterboard or any. So I keep using proprietary terms. Sorry, but any plaster or gypsum sheet does have a small R value. Typically, R values are around 0.05. I think it provides a very minimal insulative value, but it provides some insulative value. and it certainly stops the simple transmission of air. So it stops drafts, etc. But the reason we would use plasterboard or gypsum board instead of, say, plywood for internal linings, or cement sheet or steel sheet for that matter, is that the plaster or the gypsum in the board takes up moisture from the room and then puts moisture back out into the room to help, I guess, for want of a better term, provide a bit of a moisture flywheel for the room. So when there's a lot of moisture in the room, when there's high humidity, it takes moisture in. When there's very low humidity in the room, it gives moisture out. And if we didn't have that function, what we would have happening is a lot of water collection on walls and ceilings where we have differences in temperature. So I guess everybody has seen that previously, where you've had a nice warm house during the night, and then temperatures outside dropped significantly, and you get dew or moisture collecting on the inside of your windows. Everybody seen that before? Where you get that temperature difference. So when air is warm, it can take a lot of moisture in that warm air. But as soon as you cool that air down, it starts to become denser, and the water separates out of that air, and it will collect on surfaces, for example. And that's a very important function of plasterboard. But also, plasterboard, it gives, I guess, essentially, it's a smooth finish. It's not a gloss finish. It's not a highly reflective finish, but it certainly provides acoustic qualities in that it absorbs sound. It's not as reflective as glass or concrete, for example. And there are plasterboard, gypsum board products that have been designed to help stop the spread of fire, and we'll go into that a little bit later on. Can anybody think of any other particularly traditional wall and ceiling lining options instead of a plasterboard or gyp rock wall? What's that? What's that?
Paper.
Paper. Yeah. Yes. Well.
What about aluminium? Like what they call that shit? Like they do to partition walls. A kind of steel, but it's very light. And it's mostly used in office spaces.
Right.
Yeah.
Yeah. Well, the one I know. I've seen, in offices I've worked had aluminium channels with a sort of acoustic board in between them.
Yeah.
Yeah.
Oh, brick with a window.
Brick and render, and then some scratch coats and smooth plaster, so hard plastering. Yeah. Any other?
I don't know what it's
I
called.
say glass.
Glass. Yeah.
On partitions, like I don't know.
Yeah.
There are some screeded glasses, like what they call it? Is it sandblasting? Where they do some design on the glasses, some partitions.
Oh, etched glass.
Yeah.
So when sandblasting. Sandblasting.
Yeah.
Yes. So they use sandblasting to etch the glass. Yes. To put a picture in there or to obscure the glass.
Yeah.
So you can't see through it. Yep. Yeah. So certainly for internal wall lighting. Yeah. Any others?
I don't know what it's called. We used to have it in our bathroom. It was some sort of metal because it was reflective on the ceiling.
Yeah.
And they were just beams, or I don't know, they were beams. They were long, so they must have attached from one wall to the other.
Yeah.
And it sort of went like this. So I don't.
Right.
No idea what it was. It was very original from my dad, but
Yeah. No,
it
that
was like a mirror ceiling. So
no, that one I have not seen.
No.
So that was only in the bathroom though.
Yeah.
So it was a moisture resistant.
Yeah.
Metal sheeting. But one type of metal sheeting I have seen a bit of, and something which is actually quite desirable from a historic perspective, is pressed metal ceilings. So has anybody seen pressed metal ceilings in old buildings? So typically you've got thin sheets of metal, probably around 0.48, 0.6 base metal thickness, that have been embossed with pictures. So
Cubes.
Yeah. I will see if we can grab another screen up. And get some images happening. So this type of thing, has everybody seen any of that before?
Yeah.
And there are still people in Adelaide that do manufacture pressed metal ceilings, predominantly for historic restorations and the like. Another typical, a historic form of lining walls was what's called lath and plaster. Has anybody had any experience with lath and plaster before?
Is it like clay?
No, it's not like clay, but actually, essentially, that's where it derives from. So the older technologies, or when in the very early days of white colonisation of Australia, we had buildings being built called wattle and daub, which basically poles stuck in the ground and mud slapped up into those poles. The poles will take up moisture from the mud and expand while the mud contracts, and those walls actually stay relatively well sealed because they regulate each other's moisture. And then following on from that, there was the technology, or I guess it was developed in Europe, whereby you would have timber frames for buildings, and then you get all these small pieces of timber and nail them between your upright members of the frame, and then you put a cementitious render on them. So you work that in, and then you plaster over the top of that. So what you don't have is you don't have a solid masonry wall. You've actually got little pieces of timber that hold a layer of plaster. So this, has anybody seen this before at all? Yeah, it was certainly more popular in the States than it was in Australia. What's that? And ceilings, a lot of, but they're, not so much in walls in Australia, but certainly a lot of ceilings have been done in lath and plaster. And so you may encounter this in some restorations or addition work that you do. It can be easily spotted by the way that it cracks. It doesn't crack in a uniform fashion. You get all these small cracks that sort of lead off in lots of directions. And that's how you can pick a house that has lath and plaster ceilings. You'll see these fine cracks.
You scroll down, up.
Scroll up.
Yeah, if you go back. There was a ceiling. There's a ceiling. A bit more. Yeah, it's working.
Yes. Yeah. So that's it being installed. Yeah. Yes. Like that. Yeah. So following on from that, because we have good supplies of materials that are required to form plaster of Paris, and also lots of gypsum in South Australia or in Australia. And also because of the benefits and practicalities. We've moved significantly away from those older finishes and by and large, plasterboard or gypsum plaster in sheet form is used for lining walls today. So it enables a smooth, seamless, easily decorated finish, so you know that your paint's going to bond well to it. Suitable wide range of roof and floor structures. Surface or flush-mounted light fittings can be used, so it's easy to cut and core and mount features into. Can permit flexible location of internal non-load-bearing walls. When we use plasterboard tiles or suspended tile ceiling systems, we also have to think about the location of walls. Well, you may not, possibly aesthetics is not an issue, but because we're dealing in increments of 300 millimeters, 450 millimeters, or 600 millimeters, we want our rooms to be of those dimensions as well. Otherwise, we end up having a scenario where we have half or 1/3 or even a random percentage of a tile left over at the end. Also, another important point in regards to that is, at times, not all of your ceiling joists are going to your spacings of them, because your rooms are not in increments of 600 millimeters. Let's say we're specifying just your standard flush jointed plasterboard ceiling system, so it doesn't really matter what the size of the room is. Our ceiling joists are not always going to line up to 600 millimeter increments. What a builder will do, despite what you put on your drawings, is always put your, well, actually I'll draw it maybe. This is a better way of specifying it. So, got a ceiling space here that I can fit, say 1, 2, 3, 4, 5, 6 ceiling joists across there. And so we've got to get our ceiling joist in there, because we've got 600 millimeter increments, and it's say it's 3.4 meters. So we're just slightly shy of 6.6, so 3.6 meters. The builder will always put the ceiling joists in at 600 apart, all of them, and then this last one at a gap of, in that case, 400 millimeters. The reason for that is that the sheets of plasterboard come in 600 millimeter increments. So what we don't want to do is go say, all right, space joists at 500 millimeters, for example. We could write down the drawings. Okay, 500 millimeters, 500. Give all our dimensions to dimension the whole thing up. It's not going to happen like that. Because if we do 500 millimeters and we've got 1200 millimeter sheets, our sheet joints are going to be there, and they always have to happen.
And we really give you the sheets.
Yes, it will. We'll look at build with sheets. So, builder is not going to do that. Builder is always going to set them at 600 millimeter increments. So,
and the width of a sheet is 120 millimeter, right?
No,
1200 millimeters.
That's
1200 millimeters. Yeah.
1200.
Yeah, 1200 millimeters. Or some sheets are only in 600 millimeter dimensions. Others are in 1800 millimeter dimensions or 2400 millimeter dimensions. And I think you've also got 1350 millimeter dimensions as well, and that's the 2700 high ceilings. So for 2400 high ceilings, that's simple. It's two 1200 millimeter sheets, but for 2700 high ceilings, we have to go to 1350 wide plasterboard sheets. Fire-rated ceilings provide protection for surfaces mounted above the ceiling and can accommodate air conditioning ducts, dampers, bulkheads. and access panels, etc. All these things you see up above us. Now, this may or may not be relevant to your design practice, but it's important to make mention. Where a level of finish is specified, refer to Australian Standard 2589.1 for additional framing and fixing requirements. So, AS 2589 states, jointed areas are therefore at best disguised to create the illusion of flatness or uniformity by careful... Oh, and please excuse the spelling in this slide. I noticed that earlier, but can't change it. So careful consideration and control of factors such as substrate quality, lighting type and source, as well as decorated surface gloss levels. The methods for installation and finishing of these materials is outlined within this standard are best on the based on best practice experiences in both New Zealand and Australia. So it basically tells us what we already know, that we don't want to have joints obvious unless they're specifically designed as expressed joints. So unless we choose to have expressed joints, we want those joints to be invisible. We don't want people to be able to tell where the plasterboard sheets are joined, and that level of finish may be dictated by the lighting scenario or the gloss finish on the paint. Was that?
You always tell.
Not always.
Well,
yeah. So different applications for plasterboard may require different specifications according to where it's used. There are 5 different levels of finish. Level 0, this level of finish may be used in temporary construction. Nothing more to say. So that's just slap some lining on there to stop dust or whatever transferring through. Level 1, for use in plenum areas above ceilings. So the area above the ceiling, that's known as the plenum. So between the ceiling and the underside of the next floor, that's what's known as the plenum. So for use in plenum areas above ceilings, in areas where the work would generally be concealed, when building service corridors and other areas not normally open to public view. So just quickly, all joints and interior angles shall have tape embedded in joint. Surface shall be free of excess joint compound. Tool marks and ridges are generally acceptable, with accessories optional. It specifies discretion in corridors and other areas. So still has jointing tape and jointing compound, but it's not flushed very well. Level 2, for use in warehouse storage or other similar areas where surface appearance is not a primary concern. Same for the others. Except some minor tool marks and visible edges are generally acceptable. Level 3, for use in areas which are to receive heavy or medium texture spray or hand applied finishes, or where heavy wall covering paper is to be applied as the final decoration. This level of finish is not generally suitable where smooth painted surfaces or light and medium weight wall coverings are specified. So the people installing the plasterboard, gyprockers, may be able to get away with a slightly lower quality of finishing if they know that it's going to have a textured coat over the top, or it's going to have wallpaper over the top, which is not particularly common. So all jointing compound should be smooth, scraping off nibs and ridges and the like with the edge of a trowel. Level 4, this is generally the accepted level of finish for domestic construction. It's used where light textures or wall coverings and smooth textures finish are illuminated by critical lighting, and where smooth textured finishes and satin, flat, and low sheen paints are illuminated by non-critical lighting. Level 5, this level of finish is for use where gloss or semi-gloss paints are specified, or where critical lighting conditions occur on satin, flat, or low sheen paints. So where we have direct lighting or lighting perpendicular to the surface. Where fire-resisting construction is specified, the details of the manufacture of the relevant testing system shall be adhered to. So what we have and what we've mentioned before, when we build buildings close together or adjoining, we need to have them separated by a firewall. Now, one very easy way of making a firewall is to make it out of solid masonry. So we can just use concrete blocks or bricks or something, ensure all the gaps are correctly filled and carry that wall to the underside of the roof covering, and we have a firewall. But masonry walls are expensive and they're also heavy. In areas of reactive soil, we want to minimise the weight of our buildings, and also with not only developer-driven construction, but also in terms of private constructions, people want to keep the costs down as well. And masonry walls can be quite expensive and also difficult to fix too. And also plasterboard manufacturers have essentially wanted a slice of the pie in this scenario. So they've developed walling systems that will give the fire rating levels that are required for fire separation walls. So we can actually use a timber framed wall as a fire separation wall. We're not going to design them ourselves because for our individual practice or individual jobs, we are not going to have the resources required to do all the testing. But various different walling gyprock or plasterboard manufacturers have designed and hence specify their own systems for fire-rated walls. Yeah, party walls. So in systems comprising more than one layer, so in construction of our walls, I'll show you through there's a document linked to on Moodle with the CSR Red Book. I'll show you that later. But in the construction of our fire-rated walls, we have some key features. One of those features are that there is almost always a fire-rated plasterboard specified as the external lining to that wall. And typically it's in double layers of plasterboard. So some details we'll see, and these are details in plan view. Well, I might have to grab a razor soon. Another room. So one of the details we'll see is we'll have our timber studs like this. So this is in plan view, and then we'll have one layer of plasterboard, and then let's say we've got our joint there, and we'll have another layer of plasterboard which will have its joint down here, for example. So we have, and then same on the other side. Except we have a joint here. We want to avoid having a joint there in our next bit of plasterboard, so we'll have a joint here. Well, actually, that's going to happen over the studs. Sorry. Excuse me. And then our next layer of plasterboard there, like that, for example. So that's one detail that you'll see where you have timber studs, insulation, and several layers of plasterboard. Another detail that you'll typically see the fire-rated walls, the studs like this, insulation between those studs, and then our layers of fire-rated plasterboard there, like that, and then continue on, like the stud here, and the stud there, for example. Or we'll have a staggered stud scenario. That's whereby we have a stud there like that, stud here, and then our insulation that folds between the two, and our fire-rated plasterboard on the outside. These So is that fairly clear for everybody? A bit messy drawings.
Yeah, this one
There
is
it
not really clear, the first one.
Yes.
Yeah, like the first joining you did there, if there is no stud, did they just screw the board to depth of, or you look for a stud?
Yeah. No, I did a really bad thing in drawing this.
Oh, okay.
I didn't think to put my joint over top of a stud.
Oh,
Always. So our joints, our joints of our first layer of plasterboard always have to be over a stud. So, and we're fixing in there. Thanks for picking that up. That's a very good point. So, because we've got our studs at 600 centres, for example, and we've got 1200 millimetre sheets, that means that we can have that joint there, and then that joint of that sheet over that stud, and we don't have any opposing joins of our first layers of plasterboard. So those joints always have to be over a stud.
Does it have any difference, required difference between each joint, between the first layer and the second layer? For instance, you know how they do measuring works, like the English bond?
Yes.
They do
Yeah.
half of the brick,
bond. Yeah.
to each layer. Yeah. Does that apply as to this one as well?
It does.
Where you have,
yes.
yeah, sort of that kind of
Yeah.
thing.
Yep, exactly. Yeah. So if we're to look at that in elevation, so our studs behind, like this.
Yeah.
We'll have our first sheet here, like that,
Yeah.
or going over those two studs,
Yeah.
and then our second sheet here, like this,
Okay.
and then we've got another row of
Yeah.
studs here, another row of studs there, and then
Okay.
sheet happening like that. Yeah, exactly. So we'll stagger those sheets both in that horizontal or in that vertical fashion, and also in that horizontal fashion between the two. So obviously, with this first walling system, we can have a very thin wall, and so we're going to have 90 mil. Actually the minimum is 70 by 35 mil studs, but let's say they're 90 mil studs, and then 13 millimeter fire check either side. So we're 52 millimeters plus 90 millimeters, so 142 millimeters total width of that walling system. This walling system, we're probably going to be around the 250 to 260 millimeter width, depending on our cavity between. And this system here, we're going to be looking at around the 190 millimeter width for that system there. But in terms of acoustic benefits, we're going to have much better performance from this system and this system than we are from that. Can anybody think of why that would be? Why would we get much better acoustic performance with staggered studs or double leaf walling than we would?
You've got a break.
Yeah, exactly. We have
Not continuous.
Yeah, exactly. We don't have any continuous connection from one surface to the other surface, because sound transmission happens in several ways. It happens through the air. So if I was to, let's say I fully enclose this room, but I drill a hole in that wall, I can still have somebody standing on the other side of that hole, listening in. I block that hole up, you'll hear maybe a tenth of the amount, because sound will travel through any gaps. But sound also travels through things via contact. Like the way the guitar works or drum works, is you get a vibration, and that vibration is carried through something. And the way our ears work as well, we have a little eardrum in there that hits tiny bones in there, and it carries that sound. We've got receptors further on from there. So if we can separate all of those elements, we get far lower sound transmission through there. And we'll cover sound transmission a little bit more later on. So in systems comprising of more than one layer, joints and successive layers should be staggered. So that's what Nimi was talking about. In the case of walls sheeted on both sides, joints should be staggered on opposite sides of the wall. Sheets should be cut accurately and neatly so as to minimise gaps between sheets and the abutting floors and ceilings. Penetrations in systems are allowed only if installed in accordance with a tested system. So we're not allowed to compromise our fire-rated wall with, by drilling, by sending pipes through or something like that in a manner which hasn't been specified by the manufacturer of the plasterboard product that we're using. Only paper joint reinforcing tape should be used in joints. Can anybody think why that would be? You think paper, that's combustible. Why would we want to use paper?
Because of the fire resistant properties, I think.
Yeah, and how is paper more fire resistant than Dutch tape, for example?
Duct tape can melt.
Yeah, no, exactly. It doesn't melt. Paper does. Yeah. Paper will keep its size and shape in the presence of heat, and so we don't want to use anything with polyethylene in it or any of the more volatile petroleum-based products. Mechanical fixing should be the only fastening system used. The use of adhesive is not permitted, and that's for the same reason that mechanical fixings under heat are still going to stay fixed, whereas liquid nails, for example, you heat that up, it may go soft and separate. Acoustic rated systems. Building regulations allow the use of gypsum plasterboard in multi-residential and residential construction to achieve specified levels of sound reduction. Where sound-rated construction is required, the details of the designer of the relevant system shall be adhered to. When installing sound-rated systems, attention should be paid to the following. The acoustic performance of the finished wall system may be compared by reducing the results of airborne sound transmission losses derived in Australian Standard 1191 into a single representative number called the sound transmission class. So, as with many other scenarios within the National Construction Code and associated Australian standards, you have different classes for buildings in regards to sound transmission as well. So, semi-detached dwellings are not going to be in the same sound transmission class as high-density dwellings, for example. Or a residential application is not going to be in the same sound transmission class as an office, for example. Site conditions are usually less than ideal and less meticulous. Care goes into sealing the perimeter and penetrations. All right, okay, yes, I see what that's getting to. So, what we have in regards to the specification of the acoustic performance of walls, there is some leniency within that Australian standard. So, for example, we will have, let's call this System 1. System 1 has been tested in the CSR laboratory, and it's got a rated sound transmission resistance, or weighted sound transmission resistance of 50. So they go, look, that will, and we'll go a little bit further into that later, but So our measure of sound transmission was what's called an RW value, and in the laboratory, this one stacks up to an RW value of 50. It only has to perform to an RW value. It's called a DNTW value when measured outside the laboratory, but it only has to stack up to 45 when it's measured outside the laboratory. That's because that Australian standard accepts that scenarios where something is constructed in the laboratory does not always accurately match, or when we build something on site, we cannot accurately match that on site. So there is a little bit of variance, and that's what this second one, point B, refers to. So site conditions are usually less than ideal, and less meticulous care goes into sealing the perimeter and penetration. Laboratory STC sound transmission class values may not be achieved, but that's actually, there is some accommodation for that in Australian standards. Other elements of the building can seriously affect the acoustic performance, particularly flanking paths of sound. The acoustic performance of other elements of the building, such as doors, windows, ceiling joints, and roof space, needs special consideration when designing to achieve a given sound reduction level. So we can have confluence in factors, of the building that will, compromise our measurements on site. Back to fire ratings again. Key points to consider: fire mastic must be used in fire rated systems where caulking is indicated, and is also recommended for caulking acoustic systems. I think it's very much a no-brainer. Recessed lights must be installed so as to prevent damage from temperature rise and to prevent the risk of fire. So they have to be installed as per the manufacturer's specifications. Plasterboard must be stacked flat, properly supported on a level platform or on support members which extend the full width of the sheets, which are spaced at a maximum of 600mm centres. As normal, timber members to which plasterboard will be fixed must comply with Australian Standard 1684, Residential Timber Framing Code, and AS 1720.1 timber structures design methods. Be spaced at no more than 600mm centres, and as the point I made before, be spaced at no less than 600mm centres as well. Have a minimum fixing face width of 35mm. Have a timber moisture content at the time of lining of no more than 16%. I think we covered that earlier on in regards to, did we cover timber as the material going to seasoned timber and moisture content? No, we didn't cover that. So, what's that?
2014,
yeah, 2014. Yeah. So when we cut timber down, it's freshly cut timber has a moisture content of 100%. We regard that as it's not that the timber is 100% water, but it has as much water as it can possibly take. Very quickly, that reduces to 80% moisture content, and then after that, the timber is kiln dried or seasoned outside. So seasoning outside takes a very long time, or seasoned in controlled conditions does take a very long time. Typically done for hardwoods, etc., because hardwoods can split and as they lose moisture more than our softwoods like pine. But particularly with pine, we can kiln dry that, and we can get the moisture content down to about 10%, and then it leaves the timber shop at 10%. And so when we're talking about 16%, that's just a little bit more moisture than the dry timber that you would buy straight from the seasoned timber that you would buy from the manufacturer or supplier. Steel framing to which plaster will be fixed must comply with Australian standard for 600 cold formed steel structures. Be placed at no more than 600mm centres. Once again, or have a minimum fixing face width of 32mm. Be no greater than 1.2mm base metal thickness. Can anybody think why we shouldn't have anything more than 1.2mm base metal thickness? Yeah, fixings. It is, when you exceed 1.5mm or 1.2mm base metal thickness, driving, or you can have tech screws with metal heads that they'll drive into 3 or 4mm steel, but it is not easy. You have to be providing a lot of pressure like that, and then it goes. So you want to have a thinner, lighter gauge steel, so you can fix in quite easily. Ceiling tiles. So provide, I guess, very practical way of doing ceiling. In that you can have, like in this case, your recessed lighting, so all the lighting is flush with the ceiling. You can have easy access at all times to the plenum for accessing services, etc. You can replace any damaged tiles. So if a tile gets damaged for whatever reason, be it moisture from the roof also, it's very simple to take one out and to replace it. And you can also use acoustic tiles in this scenario. So tiles that will take up a lot of that reflected noise and keep a quiet space. Only issue with suspended tile or ceiling tiles, people don't find them aesthetically pleasing. Also, there's that association with offices, with work, with institutions, for example. So it's not something you typically see in residential construction, despite the more pragmatic aspects. So provide easy access to maintenance, come in a variety of styles, are primarily made from mineral fibre blends. And as we can see here, can be hung in various different fashions. So that's square edge, which is by and large the most common. A shiplap edge, where we don't see any of the hanger. That's for those sitting a bit further away. What we have is a tongue that goes underneath the hanger, and then a small tongue that sits on top, and a tegular edge, which is a recessed edge, an expressed joint, if you were. Ceiling suspension systems should be designed to Australian Standard 2785, suspended ceiling design and installation. Most ceilings are not trafficable unless stated and are designed to carry the weight of the ceiling only. Yeah, so not really what you see in the movies. People passing through. Where a trafficable ceiling is required, installation of proprietary trafficable ceiling systems such as Rondo walkabout is necessary. So Rondo is a company that you'll see a lot of, and you'll see mentioned in the CSR Red Book, I think, because they are associated with companies, or I'm not sure the ownership structure there, but they are a major supplier and specifier of suspended ceiling systems. Control joints are to be installed in both fire-rated and non-fire-rated ceilings. Typically within residential construction, we don't have to have control joints in our ceilings because in continuous interior sealing areas spaced at no more than 12 metre centres in both directions. Typically, we won't have a room which is longer than 12 metres in any one direction. That's fairly abnormal to have that. But if we do, well, then we need to provide a control joint in that ceiling somehow. That's to ensure that we don't, well, no, it doesn't ensure, but it helps to mitigate the risk of having plasterboard cracking in a non-controlled fashion.
Sorry, what's the control joint?
Control joint. So control joint is
it like the flush joint or something?
No. So it's a specifically weakened type of joint. So it is a joint that will crack along a specific line.
Okay.
So our standard. Articulation joint. Yes. Just bear with me just a minute. I'll duck next door, see if I can grab a razor for clearing that up. I think that's always coming and locked the door. Is there one? There's a whiteboard there. Whiteboard, yeah.
Tissue.
No. Right. Toilet paper.
Flipped out. Perfect. So our standard joint is going to happen like this. So we've got a ceiling joist happening here like this. We've got very wonky plasterboard happening. With a joint happening there. We've got our recessed fixings with our plasterboard screws, so bugle ends on those screws. Then we will have some adhesive and tape placed on that joint, and we'll get a slight sort of cupping happening in there, which is a good thing. And then over top of that, our flushing compound is put. So flushing compound is troweled on with our our nice wide handheld trowel, and then that will be sanded, and then a really fine coat once again with flushing compound, and that is sanded to give hopefully an imperceptible joint. For some reason, so let's say we've got a ceiling that's more than 12 meters. But this is just, I guess, close to arbitrary. We've got some flexure happening in the building for whatever reason. With plasterboard being fixed to all our other joists, and that being able to take some tension, this joint is going to crack, or if it's really well fixed, we'll get a crack back here or something like that. But what I'm trying to say is this joint will crack in a fairly random or seemingly random fashion like that, and it will look terrible. What we would prefer in this scenario is to have it flushed and then have a cut placed in here, very fine cut, so that if there is any separation, it separates in a very smooth, nice, straight line, which can open up a little bit and be imperceptible to the amount it's opened up, or close up a little bit. So to mitigate our crazy cracking. Does that answer the question about the control joint?
Yeah, somehow it's confusing.
Yeah.
I'm trying to figure out like what that's control. That what you're trying to say is like it's on a joint, and a particular joint, the crack that happens on the joint.
Yes,
Right.
yes. Well, when we have really long runs of sealing,
Yeah.
because buildings do this a little bit,
Yeah.
right?
Yeah.
Almost we can't see it, but they're doing that a little bit. When the buildings are doing this a little bit, and we have a really long ceiling, there's a high chance it will crack somewhere.
Yeah.
We want to control where that crack happens.
Okay.
We don't want that crack to just happen anywhere.
Okay.
And so we want it to happen. We've decided, okay, right in the middle there, we want a joint that's going to crack right through the middle. Is that? Yeah.
Yeah. Okay.
Yeah. So you'll hear the term control joint used in so many things, particularly in concrete slabs, like for industrial, for warehouse.
Yeah.
We've got really big long slabs. We know that it's going to crack somewhere. We want to control. We want to ensure that cracking happens in a specified place. Control joints in walls, in masonry walls, every 6 meters or so, we have to have a control joint. Same thing. So same terminology. Control joints may be positioned to intersect light fixtures, heating vents, and air diffusers. So for other penetrations through the ceiling, just the same as you would put a control joint right up the side of the doorway in a masonry wall, for example.
So it's more or less like an expansion joint.
Yes. Yep. An expansion joint. In exterior ceilings placed at not more than 6 meters. Control joints continued. So in 12 meters for internal or for exterior ceilings placed at no more than 6 meters, maximum centers in both directions. Or at changes of framing type. The reason we do it at changes of framing type are that the frames, different substrates or different framing types will behave in a different fashion. And so at that change, that's where you're going to get the most, the greatest likelihood of any flexure happening. I would also add that in some scenarios, you will have to design a place with a control joint through the floor. One of those scenarios is where you would have, let's say, a system like delta core concrete flooring placed on a supporting beam. So delta core concrete flooring are these concrete panels that can span a long distance, and they're hollow concrete panels. When we use such a system like that with these hollow concrete panels, and then we finish over the top, because there's flexibility in that, or there's flexibility in the structure, but not really flexibility in the finish that we put over the top, we will have to provide control joints in that floor. And so we want the floor to crack in the specified places where we want that to crack. When we have a control joint in the floor like that, we have to think about continuing that control joint through all the materials up above until the roof. We don't typically put control joints in roofs because we've got a lot of flexibility in the materials there. But for walls and for ceilings, etc., we carry that control joint all the way through. So we would also have a control joint in a ceiling above where we have any control joints in walls and floors. What we do not do is have a control joint in a ceiling above a brick control joint. The reason we don't do that is because the two systems are isolated. When we have a brick veneer wall and we have a control joint in the brick veneer, that doesn't impact upon what's happening with the actual structure of the building. Just be aware of that.
Oh, sorry, you mean like the external face or?
Yes, yeah.
Okay.
Yeah, because with our brick veneer, the timber frame is a structural component of that wall. So we can have control joints in the external veneer, but that doesn't relate to what's happening in our ceiling. So control joint details for non-fire-rated ceiling, or see if I can, I'm sure I can get that a little better. What we have, so we have a proprietary design system there. So our two furring channels, Rondo P35 control joint with set finish. So we've got a possibly an aluminium T-piece in there, and a 15 to 20 millimeter gap. Or control joint details for control joint detail for non-fire rated system. We have a 15 to 20 millimeter gap, and what's this beading in here? It just says control joint P35 control joint with set finish. No, it's a bit too furry to read. But your manufacturers will
do have aluminium piece in the control joints.
What's that?
Like the finish that you're talking about, is it like you said it's an aluminium finish?
This one is, well, one of them is an aluminium piece. So it's an aluminium, it's a piece that looks something like this.
Yeah.
That's 15 to 20 millimeters width. And so that provides just a smooth line, and the plasterboard can be on top of that, doing what it wants. Or in this scenario, we've got a cut, and then we've got some type of beading in there, but it's a little bit too furry for us to see. Possibly that would be. If you looked up Rondo and Rondo Systems control joint plasterboard ceiling, you'd be able to get those details.
So what's the essence of that aluminium or steel that is there?
Yeah.
What's the real function? Just to give it an artistic or aesthetic view.
Yes. Yeah.
But the main function is defeated. The control joint or
no, the main function is still there. So the main function of the control joint is to enable some moving of the ceiling without any cracking. So if you have an aluminium jointing piece in there that allows the plasterboard to move a little bit, but doesn't show up any cracking, then it meets its performance, what's demanded of it.
Okay.
So to search for a copy of the Gyprock Ceiling Systems Installation Guide, read the framing section, have an understanding of the design considerations and detailing requirements to achieve certain FRLs, and make allowance for MEP penetration. What are MEP penetrations? Don't know. Maintenance. Services. Yeah, penetrations. MEP. No, don't know. Yeah. So, also download your own copy of the Gyprock Red Book. This book contains all the fire rating scenarios you could be faced with and how to achieve FRLs using various systems. To fully understand this book, once downloaded, go to the chapter how to use this Red Book, and then then go to page A17. It's actually, for your information, B17. So please note that. Fire testing and familiarise yourself with all the information on this page. So we'll go to that right now. So what I did is okay, well, I've lost the page now, but from Moodle there's a link to the CSR Red Book. And this is what you will this is what you will find within the Red Book. Scoot out just a little bit so we can see the whole thing. So introduction, product and design. So section B, that's where we've got the information on fire rating. Section C, steel framed wall systems. Section D, timber framed wall systems. And then the Eco 8 wall and ceiling systems. Masonry wall systems, external wall systems, etc., etc., etc. So we'll go, first of all, we'll go to B17. Go to section B. Actually, well, we'll just cruise down through B a little bit, actually, if you don't mind. So they're plugging their various products, etc., etc. Oh, right, mechanical and electrical services. Yeah, services. Fantastic, thank you. Yeah. So, of our walling board products, so we've got CSR, Gyprock, and we've got we've got various different suppliers, NAUF or KNAUF or another one. So we have our various different suppliers of them. Hardy's, yeah, Boral, yeah, and they all pretty much have one of these equivalents. So we'll just run through the what Gyprock call theirs. So they've got Gyprock Plus. Why they call it Plus, I don't know, but that's your standard 10mm plasterboard. Yeah, or if they called it Gyprock normal, it wouldn't maybe have quite the same sheen anyhow. So, but it's your no frills 10mm thick plasterboard. So it's your standard plasterboard. It's not going to be used in wet areas. It's not going to be used in fire-rated systems. It's not going to be used externally. It's not going to be used in high impact. It's just your standard, but it will do your standard walling. Super Seal is also 10mm plasterboard, but it's strengthened for use in ceilings. So we need a little bit more strength to resist sag in ceilings than we do in the walls. What's that? Come to yours? Maybe they use Gyprock Plus on the ceiling. Super Seal. Possibly it got moisture affected as well. Didn't glue it.
No, they glued it, but last time we glue all the first.
Right.
So that's still close. It's still
Yeah, right. Yeah. AquaCheck. So that's the plasterboard that can be used in wet areas. So in bathrooms, but then also laundries. And you probably want to, if you're pedantic, probably use AquaCheck in your kitchen areas as well, behind any areas that are going to receive moisture. So once again, 10mm. Sound check. So we would use sound check plasterboard for separating walls between buildings, possibly walls to separate teenagers from the rest of the house. In areas where we've got high traffic noise, basically anywhere where we want to minimise sound transmission, or in recording studios also. No, I don't. You? So plasterboard sensitive, so approved by the National Asthma Council. Sensitive provides moisture and mold resistance. So better choice for allergy, asthma and allergy sufferers. Super check.
Does it say with the sound check how, like an R value or something?
Not in this table.
And there's a combination.
Yes, and that. Yes. Yeah.
Warning system.
Yes,
Yeah.
exactly. Yeah. And further on down in the red book, it's got a table with many different warning systems. So it's this warning system, that one, that one, that one, that one, that one, etc. It goes over 4 or 5 pages. And they have things like, sound check used in this scenario has an RW of this. Yeah, but this is just a simplified table that shows, the products, and then we've got our little tick boxes here for, moisture resistant, enhanced sound resistance, low VOC, and low volatile organic compounds. Although it looks like everyone is ticked for that. Super check, manufactured with a very dense core and heavy duty facing, producing high impact and sound resistance. Super check has a white paper face to assist in paint covering. So use that for corridors and so on. I'm not sure, I'll just have a quick flick through, see if they do. Yeah, so they have their impact check there. Commercial, so standard plasterboard. It's a 13mm plasterboard or an 8.5mm plasterboard.
These materials, are they specified in the market or in the shops? Like when you go to buy, are they really specified the way they are here? Like you said, acro or sound tracks, or what they call them?
Yeah, sound
checks. Yeah. Are they specified that way in the market?
Yes.
If you tell them you want to buy sound check, they bring that one back.
Yes. Yeah.
Oh, okay.
Yeah, definitely. Yeah.
Okay.
And they're colour coordinated as well.
Right, slight colour difference.
I think on my check is pink.
Yeah.
So it's that mass, is it?
What's that?
That's what it is. Second or fourth column.
Oh, kilograms per square metre. So that's the weight. So for our commercial plasterboards, same, except 13mm instead of 10mm. And there's also fire check MR. That's moisture resistant and fire resistant plasterboard. That's for where we're going to have wet areas that are adjacent a party wall or fire rated wall. If we're designing for disabled access, we'll probably want to be using this one, the impact check. So fire graded board reinforced with woven fiberglass mesh to produce a high strength plasterboard which resists soft body damage. It's ideal for high traffic areas such as hallways, stairways, playrooms and garages, but also important for where we have wheelchair access and so on, and for people with impaired mobility that have a high frequency of pressing against walls or knocking against walls. And I haven't actually looked into these ones. The Eco 8, this product features high level. Yes, I have. Yes, this features high levels of recycled content, making it a superior choice for green building projects. So less, so 20% recycled, 21% recycled, 20% recycled, etc. There are certainly, which is a good thing, in that a lot of so plasterboard's generally fairly inert in its situation, but when we throw it away and we leave it outside and it starts to break down, it does give off. I'm not sure what it gives off, but it does give off harmful things. So we don't really want. It's not a good thing for the environment in general just to be throwing plasterboard away.
Worse than paint.
What's that? It's worse.
Probably the coatings of paint.
Possibly, yeah. I haven't looked into it for a long time. So I can't remember what it gives off, but I do know it's preferable not to just leave it lying around, let it decompose. And also shaft liner panel. So that's for where we've got lift shafts. So we'll need something that's fire rated, but also something that's going to be very strong to resist impact from people working in the lift shafts, etc., or cables smacking against the side. So that's 25 millimeters thick, weighs 19.8 kilograms per square meter, so fairly heavy panels. For that reason, comes in 600 millimeter wide sheets. So smaller sheets, yeah. So 25 millimeter thick sheet composed of glass fiber reinforced gypsum core encasing heavy duty linerboard. And also this one you may have interest in as well is flexible. So a 6.5 millimeter thick plasterboard with enhanced core to allow bending to small radii for curved walls and ceilings. With my just quick cursory look through the red book, I couldn't find what radius you can bend that plasterboard to. Yeah, but you want to know that as a designer. But yes, I have a friend who's specified this plasterboard for a curved ceiling. So you can do curved ceilings, curved walls, for example. But you have to possibly phone up or look for the brochure specific to this plasterboard to get that radius. So designed for installation as a two-layer system. So it's only 6.5 millimeters thick, and you lay one sheet curved, and then you lay the other sheet on that with staggered joints. So this specifies various different fixings, etc. So this is what we referred to earlier in the slides, page B. Well, it says A17 in the slides, but we mean B17. So fire testing. So all their products have been fire tested, and we have to meet fire resistance levels. I haven't spoken about fire resistance. Have I spoken about fire resistance levels before with you? So the way that if you were to pull out the National Construction Code and read through for design in relation to limiting the transmission of fire, very early on it will start talking about the fire resistance levels. So you've got your class of building, your building, and then within your class of building you've got your building category, whether it's A, B, or C. And then whether it's A, B, or C, will tell you what level of what fire resistance level you will need for a common wall. Those fire resistance levels are given in values like this. So let's go over to this side, load bearing. For example, if it's I think a multi-residential building, we're going to have a fire resistance level of 180, 180, 180. So this first number, that relates to structural adequacy. So we have a load-bearing wall that has to stand up for 180 minutes in a fire. Our second figure here relates to integrity. So we have to have a wall that won't get any holes in it for 180 minutes. So for 3 hours, that wall can't be breached by flame. And then the last figure is insulation. So we can't have a wall that expresses more than 180. What do we have here? So the initial temperature or the temperature at any point in an unexposed surface increases more than 180 degrees Celsius over the referenced temperature. So for 3 hours, it has limitations on how much heat it's allowed to transmit. So they have designed their walling systems to meet these various different criteria. And then obviously for non-load bearing, structural adequacy is not an issue. It's not carrying anything, and so there's just no value. There's no value put in there. So for a non-load bearing wall within our multi-residential complex, we're still going to have integrity for 3 hours and insulation for 3 hours. But being non-load bearing, we don't have to have a value for structural adequacy.
Are the numbers ever different?
What's that?
With the load bearing wall, all the numbers are always the same. Like it's 30, 30, 30.
Yeah.
Makes sense. Are they ever any different?
They are. I'm not sure about the Red Book. We'll see a little bit later on whether they have some that differ. But yes, strangely enough, in the National Construction Code, there are scenarios whereby it will say 60, 120, 60, for example. So 60 minutes of integrity, 60 minutes of structural adequacy, 120 minutes of integrity, 60 minutes of insulation.
So if you've got a monolithic wall,
yeah,
then then all three have to go. You just pick the highest number.
No, not necessarily. So for your various different building classes and hence applications, there are different tolerances. So typically your highest value, if you have differing values across your fire resistant levels, so let's say it's 30, 60, 30, your integrity is going to be the highest one, because as soon as it loses its integrity, it loses everything else. It loses its insulation. And for some scenarios, we can accept a lower level of insulation, or as determined by the National Construction Code. So they can say, well, look, it's a car park, for example. Insulation on the other side is not nearly as important as a multi-residential area, but structural adequacy and integrity is still really important. So they say, look, it has to maintain structural adequacy for 3 hours, has to maintain integrity for 3 hours, but it can only hold that insulation for 30 minutes. We're okay with that. And yeah.
But if you've got a monolithic wall,
yeah,
then it's got all these functions.
It does, except it doesn't have insulation typically.
All right.
Yeah.
So if insulation is the highest number, then you want to use that number, then you just pick the other ones. How does it work?
Yes. So let's say I wanted to build this car park, and this car park shares a wall with a warehouse, for example, and I'm a class 6, class 7 building, and I would be I'm not sure what fire resistance category I'd be in, but I go through that whole process in the National Construction Code to find out what fire resistance level I need. The National Construction Code may tell me that I only need 120 minutes of accuracy, 120 minutes of integrity, and 30 minutes of insulation. But, I feel like sort of in thinking about that, I lost your question.
That's all right.
A bit.
I'll just use common sense.
What's that?
Brick wall.
For a brick wall or like
Yeah,
I grew up in a big house.
they've got their own rating. So they can use,
Yes.
you can use Hebel
Yeah.
as your cladding wall, then timber on the outside. That's another way of doing it. The Hebel provides you your FRL you need.
Yes, that's
It's a good way of doing it.
Yeah,
So then you don't
that
need
is.
your fire check or that.
yes, yeah,
It's just different. They're tested in laboratories and they're given those figures.
yeah. And so
The thing is, if you've got to get to a material that's not tested before,
then
You've got to get it tested before you're allowed to install it, or else you won't be able to pass it through the building rules. Or
Yes.
But I won't allow you plus. Even though maybe belt hasn't been tested, you've got to go out and test it.
Yeah. So
that's
yeah,
why it's easier just to refer to something that's already there.
But many of your materials will have been tested at some point in time previously. I know of multi-residential mud brick houses, for example, in Bowden or Brockton. In that bit there, there's a whole community development of mud brick houses with mud brick party walls, for example. So somebody
would spend the money to get it tested, but you're going to do something yourself.
If a house has been built before in South Australia with it, then it should have been tested.
Yes, yeah, and so you can track.
May not have been tested because it's 100 years old.
Yes, well that but those ones I'm thinking of, I think they were built in the 90s, so they would have been tested. Same thing for rammed earth walls. There are plenty of, in that same area there are these, once again, community built houses with rammed earth separating walls. Brick walls certainly been, of course, solid masonry walls certainly been, cavity certainly been tested, stone certainly been tested. So yeah, pretty much everything you can think of will have been tested, except for maybe hempcrete. I don't know. You'd have to see about the suppliers of that. They may have had it tested or may not have had it tested. But
so if you want to bring something from Holland that may be tested over there, you may not necessarily get it.
Yes.
Through.
Yeah.
I'm not going to bring something in from Holland.
Yeah.
No, just give me an example.
Yeah.
You'd have to get a recheck.
It has to be in South Australia. Yeah. It has to be in South Australia, even Australia probably.
No, you can import. What's the stuff being imported? The importer wants to
Oh
get
no,
the license.
I mean for the tested thing.
They can you have to get tested in Australia as long as they've got good compliance.
Yeah, as long as it I don't know exactly what it needs to be, but as long as it meets so the criteria of the National Construction Code say that it has to be tested by an engineer an engineer with relevant qualifications, I think is how it's worded.
So really you only have to find the right engineer.
Yes. Yes.
Set up to do it.
Yes.
CSIRO would have done years ago.
Yeah.
You get private firms. Glazing's the same. They do glass testing. There's a few labs in Australia that do that.
But it is very expensive for CSIRO. Sorry. It's very expensive for people to set up these laboratory situations to be testing things. So it's much better if you can import tests from other use or use tests that have been done previously. So that's our fire rated walls have to meet certain criteria. And for assignment 3, you're going to have to go through that process of saying, what building classification is this? What fire resistance category does it come under, A, B, or C? And then given that, what fire resistance level am I going to need for a fire separation wall? So you're going to have to go through the National Construction Code to do that. It's fairly simple. We can go through that. And you'll arrive at one of these figures. What was that? The final one. The final one is, it's a showroom and office. So showroom downstairs, office above. What else do we want to see in the red book? I think. Yeah, okay, we'll scoot down to the walling systems.
The other way down is show us the stuff that shows how they overlap the second split, how they overlap the sheets. And then you show the staggered.
Oh yes, yeah. Well,
There's two elements, right down the bottom up to
Right. So here we are in section. I don't know. I'll see which section we're in. Section C. So section C relates to steel walling systems, and so in these tables we have our various different walling systems. So system number CSR 1357. So we have 2 layers of 13mm fire check moisture resistant. We have then a cavity, insulation on one side, and then once again 2 more layers of fire check MR for non-load bearing walls. So we don't have a figure for structural adequacy, but we have 120 minutes for integrity, 120 minutes for insulation. Actually, and then for load bearing walls, we've got 120, 120, 120. Although that throws up, why do we have, I don't know why we have a rating in here of 90, 90, 90, where that one relates. Apologise, that's fairly abnormal. Okay.
It's kind of 90, but the one that says both sides.
Yeah, they all say from both sides. So
For both sides, you get a 20, 120, 120, 120, is that right?
yes.
But without both sides, for one
Oh,
side.
ACR 10%. 120, 120, 120.
That's
Don't know. Yeah, sorry, that was a bad one to pull up as an example. Okay, so the next one. So we've got just standard fire check plasterboard, so not moisture resistant fire check. Non-load bearing walls, so no value, 180 minutes, 180 minutes. Or a load bearing wall, 120, 120, 120. So I guess essentially the linchpin in here is the structural adequacy. So it's only got because we've got steel framing in this scenario, it's only going to have structural adequacy for 2 hours because that was under heat steel buckles. Yeah, creeps. So that's it for. So we have this table for our steel walling systems. We also have. I'll skip down again. IS steel framed and section D timber wall framed. So this detail here shows the multiple overlapping and staggering of joints. So here are our various different timber systems. So with your standard plasterboard, 6mm or cement seal, so wallboard, so that's cement sheet. Doesn't have doesn't meet any fire rating levels. Scoot further down to where we start meeting fire rating levels. So with our timber systems, once again, our structural adequacy is the linchpin, so it will have 60 minutes of integrity, 60 minutes of insulation, but then it'll only have structural adequacy for 30 minutes, so those others will be compromised after 30 minutes as well. But where we get into the fire check systems. So fire check outside. So this is more the type of wall we're going to be using for our fire-resistant party walls. 120, 120, 120. Yes, I think some of these will be specified masonry between. Possibly. Some studs, heavy insulation. Yeah.
Timber type of wood.
What's that?
No, the timbers are just normal stuff. Talking about the timbers, like the studs.
Yes.
Yeah, they are just the normal ones.
Yes. Yeah. Yeah. So minimum size of 70 by 35. Size. What Alex is talking about, and we haven't come across it in the tables, is a scenario, actually rather than draw it, I can just point onto here. Is a scenario whereby we'll have a double stud wall like that, and then we'll have some masonry, a masonry wall built in between there. So that will provide, so our masonry wall will provide the fire resistance level, or we would have like aerated concrete, a heated panel in between the two, fully sealed to provide that fire resistance level as well.
Because the measuring wall will go in between the two partitions that we have in there, at the middle of the two partitions there.
Yes, yeah. So a masonry wall, a single leaf masonry wall in between the two. It's actually quite common. So that's for multi-residential. Yeah. 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 So I dare say that must be a fairly cost-effective way of meeting.
I've recommended a lot of this stuff, I've been told now.
Yeah. Details about screw fixings and lapping of sheets. I think that's fairly much the extent of what I wanted to show you in the Red Book. Oh, here's some nicer looking details of single stud walls, staggered stud walls, and double stud walls. So yeah, once again, staggered stud walls, fantastic for a scenario whereby you want to reduce sound transmission. And here's details where we have staggered joints for our overlapping sheets as well. So joints staggered in a vertical fashion. So we have a joint here, that sheet goes over and joins the midpoint, etc. We have that staggering happening in horizontal fashion as well. I'll leave it at that. So, are there any questions? Any further questions, or any questions in relation to assignments for assignment 2? So, yeah. Yes. Oh, yes. Yeah. Available as per normal. Sometimes it takes me several days to get back to you.
That's fine.
Yeah. So expect that.
I'm too busy of paying this.
Yeah. Diary. Look, no, I can't tell you the date off the top of my head.
So when are we back?
My diary. Yeah, that's what I was just going to grab the date.
2 weeks off,
So 2 weeks off.
which gets us to
I think the 16th or 17th of October.
So what are we? Let's use
might
the
not
diary.
come in. Get employed. I've been sorry.
17th.
17th. Okay.
Last week.
Yeah.
Right, I'll have a big check there.
That's why you're not going to be in. All right, so fantastic. Thank you very much for making it along.